Since we can only store a limited amount of data in cache, each system needs to determine which cache update strategy would work for it. There are four main strategies that we'll be discussing about. Cache aside. This strategy first checks the cache. If the key is not found in the cache, that is, if the query is a cache miss, then we load the result from the storage, update the cache, and return the result. This is the most common strategy, and if you're building a small scale application or just starting with a new online business, this would probably be enough for you as a starting point. So as you see, in this strategy we access both the cache and the storage. One problem with this strategy is the data staleness, which means the data that resides in the cache may not be the most recent one. So to reduce the staleness, we can add a time to live attribute which says that cache will be updated after every few interval. Now, if a cache miss occurs, you see that we need three trips to return the result. One would be accessing the storage, second updating the cache, and third returning the result. So that adds to the latency to some extent. Let's think about fault tolerance too. If a cache node fails, it is replaced by a new empty node. So again, filling the cache from scratch adds to our latency. One popular tool that uses this strategy is Memcache, the write-through strategy. In this, the application reads and writes data to a cache instead of the database. Then it is the role of cache to update the main database. This is usually used when you have a high volume of updates, so you update database only once in a while instead of updating it for every single query. Imagine an app like WhatsApp where users send hundreds of messages to each other. So there updating the database every time a message is sent may not be the best strategy. So a strategy like this can be used in such cases. This can provide very fast writes to the application. There is no data staleness at all since cache is the most updated one itself. However, if the cache fails, then a new node is created from scratch and that might risk losing a lot of data. There can also be redundant data in cache, so we can again add some time to live here to reduce the redundancy. Right behind strategy. In this, the application adds or updates entry directly into the cache just like previously, but in this the cache, instead of synchronously flushing the data to database, does it asynchronously. So this improves our write performance and reduces the latency. However, if the cache goes down, there could be some potential data loss. This is quite a complex strategy to actually implement. Then finally, refresh ahead strategy. In this, the cache auto refreshes recently processed query on its own. This can reduce latency in some cases and can even reduce the data staleness. In this, the request is served directly from the cache, but the cache auto refreshes the recently accessed entries. This reduces latency in some cases and can even reduce the data staleness.